Hello, a good evening. Programmers Live once again. Don't forget to subscribe to my YouTube channel, Programmers Live, or reach me out on my WhatsApp contact. So, today I would like to start this session with at least a practice that will help us recall what we've been covering from the earlier episodes. So I remember I dropped these questions quite some episodes back, so I'd like us to pick from here, and that will be a good kickstart for our session of today. So we have a question which says write a program that converts a given number from binary to decimal. Now I think we should begin by copying and creating a comment for our program. As usual, we shall have to choose a language. Okay, so there we go. We shall say hash include. I think this is not new anymore, so using namespace standard. Okay, so definitely we shall have a main function. Now the program is converting any given binary number to a decimal. Now the whole idea about solving problems while programming is first make sure you solve the problem before you enter into the coding concept. So when it comes to such programs, we assume that someone already knows the technique that is in the mathematical bit of converting from one base to another, or from one notation to another. The most common notations are from decimal to binary, then binary to decimal, or decimal to octo, or octo to decimal, in whichever case. So we have to be sure that someone already knows how to do that. So the moment you know how to do that on paper, just a pen and paper, then it means that definitely you can borrow the logic that you have on paper and put it in a programming concept. Now, what does it mean? It means that to convert any number entered by the user, that is as the question requests, or as the problem requests, to its equivalent decimal value in programming where we are right now, it means that you have to ask the user to enter the number first. Okay, so all the logic now begins happening from there. So what we are going to do, we are going to say out so we are saying binary to decimal converter. So binary to decimal converter, that is just an opening statement. So what is going to happen? It means we shall say see out still. Remember, we've said we should request a user to enter the number, enter the binary number. Okay, we are plotting out the program now. So since I need the input to be on the same line, that will happen. So cin, definitely I should have a variable that is going to request, or that is going to store the captured number from the user. But I know someone is already thinking exactly the way I'm thinking. 1 Yeah, we rushed, we assume, to have an opening statement to ask for the number from the user. But which other techniques can we borrow if we are to do this? One, you can do it plain within the program. Two, you can use a function within the program. So the easier way for you to handle this problem in the program is what you go for. So me, I'm going to do the plain way. So maybe in your free time after watching this episode, you can borrow the same technique and try to use a function within the program. Okay, so like I've told you earlier, it means that someone is going to follow the steps or the formula or the logics that is used behind converting a number from binary to a decimal. So while I'm attempting to solve this problem, I assume that if you're watching, then you already have the knowledge. If you don't have the knowledge of how to convert from from binary to decimal, then please just pause the video, make some little research, do a few questions, then come back to the program. Definitely that will make you truly understand what we are going to handle. Okay, so right now on line 11 we are saying enter the binary number. Like I said earlier, it means that you should have a variable that is going to handle the binary number. So it means that I'll come up here and do some declaration. So I'll have binary num and I'll initialize it to 0. Okay, then I'll have another variable, let me call it decimal num, and I'll initialize it to 0 too. Then I'll have another variable, let me call it I, and I'll initialize it to 1. So I know so many questions are going to raise, but of course we are going to do an explanation. We shall execute this program and it's going to help us learn quite a lot. Then of course, if you're someone who knows the formula very well, we deal so much with so many other things within the formula. So me, I'll cater for that and I will put a 0 there. So those are just initialization. So without losing track, it means here what we are going to ask for is a binary number. Now in the next bit, let's try to convert the number given. Let's try to convert the number given, and I'm gonna use a while loop. I know we've had some previous episodes before that talk about looping, and here we are once again. So when do we begin converting? We begin converting when we are sure that the number that has been provided by the user is not equal to 0. Of course, definitely if it's 0, then we don't have a lot of work to do for that case. So I'll have here the reminder, then binary number modulus 10. Don't ask what I'm doing, I'm going to explain at a later stage. So the small number is assigned the small number plus into times I. Then I'll say I is assigned I times 2. Sorry about that. I is assigned I times 2. Okay, then I have binary num is assigned binary num divided by 10. Remember, why are we using a loop? We're using a loop because it means that following the formula or following the logics of conversion. If a number is given, there is a continuous computation for until when a value has been acquired or a result has been acquired. So that is why we place that into a loop. So outside the loop, I'll say cout I'll say the decimal version of binary num. We can say is the small num. Okay, so I think that is enough. Okay, so here we are and we have a number. Okay, here we are and we have a number. It has been sorted out and we assume it is working. We assume it is working. Okay, so what are we going to do? So back to the kitchen. We're trying to run or compile and run the application. So we shall have a value in there. It's a binary number as the program expects. So we have 1 1 1 1 code row 1 0 1 0. So we do a conversion. So it says the decimal version of the number that was provided is 112, which I assume it is a perfect value to give. Now question is, what did we do exactly? Okay, that will be the question. What did we do exactly? So let's have an explanation of the program execution. This is where the gist is. Okay, what happened in our execution? Now initially we declared a variable. Okay, initially we declared a variable, which variable was decimal num, which was initialized to 0. Then we had I, which was initialized to 1, and the binary number, which was entered by the user. Okay, so the binary number that the user entered, or that we allowed the user to enter, is that number, the number that we have just sampled there. Now upon that, remember within the while loop, okay, remember within the while loop we set a condition that if the number that has been provided by the user is not equal to 0, okay, which evaluates to be true based on the number that we entered. So we are saying that if it's not equal to 0, then you're going to continue and do all this. Otherwise, if it's equal to 0, then there is no work that is going to be done. So that was the second step of testing. Okay, this number was checked and it was not 0. Okay, it was checked and it was not 0. Are we clear? So it means that from there execution automatically had to take place. Okay, execution had to take place. So let me try to have a wider bit. Okay, there we go. I'm sorry, my screen is a bit small. Okay, now in the next bit, so the program will allow execution to take place based on the condition that was provided. So in the next bit we have so inside the loop, binary num modulus 10, or the number that was entered by the user modulus 10, okay, gets initialized to the remainder. So now the remainder is 0. Okay, the remainder for that case is gonna be 0 altogether. Now similarly, decimal num plus remainder times I here on line 20. Okay, so gets initialized to decimal num. So now at that particular point decimal num is 0. Okay, decimal num is 0. I'm trying to move slowly by slowly. Okay, so for that case what happens? So then I times 2 on line 21, or I times 2 here, because we have I is assigned I times 2, so this gets initialized to I. So definitely I is gonna be 2, because the initial value of I was 1. So 1 times 2, definitely that is gonna be 2 in that case. Okay, now the last bit that we have, which is binary num, that is line 22 here. We are having line 22 there, which says binary num, that was the number which was entered by the user. Then we are assigning the same number divided by 10, so it gets initialized to the binary number. So now the binary number for that section is gonna be this value. Okay, it's gonna be that particular value basing on the execution that we had in this section. Okay, so hope we are moving slowly by slowly. So after executing all the 4 statements of the while loop for the first time, it means that decimal is going to be 0, the decimal number is going to be 0, I is going to be 2, and the binary number is going to be 1 1 1 1 0 1. Okay, so that is the first bit of execution. Okay, that is going to be the first bit of execution. So the program flow goes back to the condition of the while loop. What does it mean? It means it's going to check again if the last value that we had is not equivalent to 0. The last value that we had gotten in the previous first execution, that value in binary num. So it's going to check again. Okay, it's gonna check again, then it will tell us if it's not equal to 0. So definitely if it's not equal to 0, then it's going to go back through the same series of steps. Again, binary num modulus 10. Okay, so it's going to be initialized to the remainder here for that case like we studied. So now the remainder is gonna be 1. Okay, then similarly decimal number. Okay, the decimal number, that is decimal number plus the into remainder times I. So that is going to be now 1 times 2. So it gets initialized to the decimal number. So the decimal number now becomes 2. Hope it is quite clear. I'm explaining this, but I'm hoping that you are following the logic that you already have on paper in trying to solve this. So once again, so I times 2, that is on line 21, I times 2. So this time around it's going to be 2 times 2. So it's going to be 2 times 2. It means that I is going to be 4 at that particular bit. I is going to be 4 at that particular bit. Remember, we are running the second bit of execution. So at last, binary num, that is line 22, divided by 10, or the previous value that we had. Okay, now it's going to be initialized. Okay, the previous value that we had divided by 10 now is going to be initialized to binary num. So on conclusion to that second bit of execution, it means that binary num is going to be containing a new value. The previous value that we had for the first execution was 11101. So in the second execution we are going to be having code row 1 0. Okay, so it means that again we are going to go back and check within the condition. Okay, so if we go back and check within the condition, definitely it's not equal to 0. Okay, so it will continuously do that. It will continuously do that. It will continuously do that. So follow that bit of explanation. So in the second last bit, of the execution, what is going to happen? So this means that we have carried out all those bits of execution. So it will mean that we have the decimal num, which will be 58. Then I is going to be 64. Then binary num is gonna be 1. And definitely the last step is gonna be that. I know someone is asking, why have I skipped some bits of execution? It's just that me, I had already done it somewhere here. So just to save time, I just wanted to take you through what exactly really happens in that bit. So guys, hope you really pick something from this. So basically the while loop here has helped us to be guided through the whole concept. So that is how we have started our session of today. So for any questions, of course, I told you, don't forget to subscribe to my YouTube channel, Programmers Life. Okay, or reach me out +2567518244973. So that was just a warm-up for today's session, or for this session particularly. But in the previous session, if you recall very well, we talked about pointers, we used pointers, we compared pointers to references. So we jotted down the differences that they had, we jotted down the uniqueness that each one of them had. But if you remember very well, we only talked about pointers. So for this session, the target was to talk about references. So down here we shall begin our session by saying references. Okay, so there we go. Now, as a reminder, up there last time we said a reference can't be null. References must be initialized after declaration. References can simply be used by their names. Once a reference is initialized to a variable, then we said it can't be changed during the time of execution. So those were key elements that we had jotted out. But for this case, let's pick more details about references. Okay, now we shall begin with a serious note. We shall say references are a major concept in C++ programming. References are a major concept in C++ programming. Now, we can say they are not as strong as pointers, but they are quite relevant in developing efficient applications. I told you I don't love writing so much, but I need to for purposes of references. So we are saying references are a major concept in C++ programming, though they are not as strong as pointers, but they are quite relevant in developing efficient programs. Okay, now one thing that you need to know is that their major application is in parameter passing, while handling functions. I remember dropping an assignment when we were talking about function calling. I told you that parameters can either be passed by value or they can be passed by reference, and I told guys to make some research. I believe you did, and for this session I think things are going to be a smooth road for you as we move along. So their major application is in parameter passing. That is when we are handling functions. So basically that is called pass by reference. Okay, the one that I'd given you earlier. So for this case we are going to get to know how do the details automatically apply. Once again, if someone asked, I know we talked about this earlier, but there is no problem in repeating. If someone asked you what is a reference, now a reference is an alias. An alias is something like another name or a nickname that you give to something, but not its real name. So it's like a replacement. Okay, it's like a cover up of something. So it's an alias or another name of a variable. Okay, so this means that the variable definitely it already has an identifier. Okay, it already has an identifier, or it already has what we call a name. So we can provide another identifier to this variable so that we can refer to this variable either with its original name or with another name. So this other name is what we call a reference. I'm saying when we are referring to a variable, we can refer to that variable by its original name because it already had an identifier, or by the new name. So by this new name is what we call an alias, or is what we call a reference. All together. Now in the next bit, syntax of reference what? Reference declaration. Declaration means I'm introducing, or the first time of introduction of that particular element within the program. Okay, so what does it mean? It means that we shall have a data type, then we shall use an ampersand, which means address of, then we shall have a reference value. Okay, then we shall assign a value. Okay, a data type, then I can use the ampersand, then I can have a new name or an alias, then I can assign a value. What do I mean by this? I can have an example. Okay, I can say int xyz is assigned 90. My variable is called xyz, then I can have a reference. Okay, so I can say ampersand ref xyz. Okay, ampersand ref xyz is assigned xyz. Are we moving? So what does it mean? What does this mean? To someone who is asking, what does this mean? This means that we have declared an integer variable. Okay, we have declared an integer variable. Let me comment here. Integer variable. Okay, and assigned a value 90. Okay, then we have declared another variable, okay, which is called ref xyz. Okay, and assigned the previous variable xyz to it. I think you're noting that. That is on line 144. So now one thing that you need to note is that while I was declaring ref xyz on line 144, I used that operator. I used the ampersand operator. I'll put it here, but this one is known as address of operator. That is known as address of operator. Okay, now what does it mean? It means that ref xyz is a reference to an already existing variable. Okay, so meaning that this is a reference to a variable. Which variable is it? It is xyz. Okay, so in short term, I can refer to xyz by using the variable name in form of a reference, which was ref xyz. I think it really makes quite a lot of sense. Now let's have a simple example. Let's have a simple program that will help us through. So this is the one that we had as a warm-up. Okay, guys can refer to that at a later bit, but I don't need this one anymore. So what am I going to do? I'm going to lose that. I'm even going to lose the explanation because I don't need it. So up here, let me try to involve some bit of strings. I know we haven't looked at strings before, but we shall. I think that will be in our next episode. But for this case, I want to show you something that is interesting. So I have a variable int age, and it's containing someone is 45. So I have int address n years, okay, address of n years, and I'm storing in age. Then once again I'm saying double salary, which is $100, 09 cents. Then I have another variable double reference payment, okay, reference payment, which is assigned salary. Okay, so briefly I can just say cout. Okay, I can just say cout employee age is age. Okay, then I can say cout the employee is now I'm using a reference. The employee is n years old. Okay, I want to show you how it shows that it is really an alias and it is containing a value for a certain variable that it was given. So here I'll say the employee is those years old. Okay, once again I can say cout he works for, okay, he works for salary. Okay, he works for salary, but I can still say he was paid payment. Okay, he was paid payment. Okay, I think you've already noted that he was paid payment. Okay, so but I'm not going to need strings here that I wanted to, but I'm not going to need that. So if we go back to the kitchen for the cooking bit, okay, we try to run again. So after execution, after running, you realize that we receive the same values. A value that was given in the actual variable is the same value that is within a reference variable. The same thing applies to salary, because salary was the actual variable, then it was assigned to the reference variable. So you still keep track of the same values. Now let's try to have another example, because in our explanation somewhere we said parameter passing, okay, or pass by reference. Now references can be used to modify the passed parameters in the function. Let's try to talk about that, and we can have an example. So we can say references can be used, okay, can be used to modify the past parameters in the function. Okay, so it means that if a function receives a reference to a variable, it can modify the value of the variable. Do you want me to write that? If the function receives the reference, okay, the reference to the variable, what does it mean? It means that it can modify the value in the variable. That is what I meant. So that is how references are really becoming so important. So here, assume develop simple program that will accept two numbers, then allow a swap of the two numbers. It means one goes into the other one and the other one goes into this one. So develop a simple program that will accept two numbers, then allows a swap of the two numbers. Let's be strict. Using functions in brackets pass by reference. I think it makes quite some sense. Now back here, of course, I don't need this program anymore. So what am I going to do? I'm going to lose the program. So here I'll need a prototype, but there is no harm in also using a pure function. So here I'll say void exchange. Okay, my function is called exchange. So I'll say int reference reference, what should we call them? What should we call the numbers? So let's call them Kato, then int waswa. Okay, so we have Kato and we have waswa. Kato is our first and waswa is our second. Okay, so what is going to happen? Of course, definitely we shall ask a user to enter the number, allow num swap. Okay, allow num swap. So what is going to happen? Because we shall need some local variables. So we shall have int num1, then sorry about that, then num2. Okay, so you can initialize, no harm, you can initialize. So say out, we shall say enter num1. So what's up with num1? Num1 we shall say cin. By the way, we can have inputs on the same input stream, so we shall say num1, but I don't like it personally, but there is no harm in using it. So I'll say num2, and here I'll say num2. So here I'll say nums before swap. Okay, so what will I have? I will have C out num1 equals to num1. Okay, so I'll have a new line below. Copy and paste is a design error, no harm in that. So you say 2, this one's gonna be num2. Okay, then we have after swap. So this one is before. Let's just leave it like that without wastage of time. We can say before. Okay, so that is it. Then we are going to have the same. Okay, but instead of saying before, we are going to say after. But don't forget, we only had a prototype to swap, but we never defined it. So what is going to happen? I'm going to copy down here, and I'm going to down here to define the function. Okay, so as usual, I told you remove the termination, then go in. Wow, so what is going to happen now? To do a swap, it is something simple. You'll need, because you already have two variables, this one is containing the first value and this one is containing the second value. Now the moment we just do a switch or a swap, so that the value of here goes inside here, it means this one is going to lose its value. I think you're getting that. So what does it mean? It means that you require to have a third variable. So this variable is going to first hold the value of this first variable before you make a swap. Then the moment you're sure you have this value inside this variable somewhere else, then you can allow this to contain the value of this second variable. What does it mean? It means that you cannot have two values in the same variable location. There can only be a single value. So keep track of the first value before you allow a swap. I don't know if I'm very clear upon that. So what are we going to do? We shall have another variable. Okay, another variable. Keep track of the first variable value before we make a swap. So I will say int keeper. Okay, so keeper is going to contain the value of Kato. Okay, then allow a swap. So it means that Kato is going to contain the value of Waswa. Okay, swap again, then it's gonna be Waswa is going to contain the value of Kato, which is already in keeper. I think we are getting the idea, which is already in keeper. So going back here, after swap, we can have a comment here. Let's do the swapping by calling the function. I think this is quite okay. So our function was called exchange. Exchange is expecting two parameters, that is num1 and num2, which are the actual parameters. So basically the whole thing was not about just playing around or having this basic example, but the whole thing was about learning how we can use references more and more and more and more. So we have managed to do that. So here we are passing addresses, we are passing references of those variables. So what does it mean? It means that if the function receives those references, then it can modify the values in the variables. Okay, so as usual, what are we going to do to our program? We've copied so well. Don't mind about this comment here, I keep forgetting these comments. Let me just say here, swapping by reference, but I know guys are attentive, so I'll come here and I'll go to the kitchen, because that is where the cooking happens. Of course, be careful of the smoke. Okay, wow, as usual we can always have errors. So it is saying we have quite a number of errors. I don't know where they're coming from. After exchange, wow, I know guys, as I typed along, they have been marking those small mistakes. Okay, so one is there. I think let's do the correction from here, that will be easier. Here I forgot to do that, the same thing I did, I forgot to do that. So what else was the gentleman complaining about? What else was the gentleman complaining about? In the kitchen, int main, exchange, whatever. I think that was the only problem. So we shall come back here, Control A, sorry, so once again we run. So Waswa was not declared in this scope. Are you serious? That is line 34. Line 34. We check again. Instead of using an ampersand, we use the $sign. That is interesting. Copy again. Hey, I love it when we get errors. It means it's exposing us to learning the language. So debugging is part. Undefined reference, exchange, int, that is on. What could be the problem, guys? Int, we do return the status. Problem is around here. So once again, so we don't get tired, because we cannot achieve before things turn out to be perfect. So the first number is containing 67 and the other one is 76. So 67, 77, 77, I mean 76 and 67. So yep, so hope we have learned something. The compiler has showed you that it really notices the references and all that. So hope we are really picking out something. Don't forget, we are looking at how to handle references, and by the way, they are going to be coming more and more so if we are handling functions. So for any questions, don't forget to subscribe to my YouTube channel, Programmers Live, and please make as much research as possible. So for this session, allow me sign out.